Okay, so in this lesson we'll be discussing about prime numbers, what are prime numbers, and how useful it is to actually help us solve problems like what is the highest common factor or lowest common multiple of two numbers, right? So first up, what are prime numbers? So a prime number has two criteria. So a prime number is actually defined as positive integers or positive whole numbers that are divisible by itself and 1. So it has to be divisible by itself and 1. And 1 itself is not a prime number. Okay? So again, I repeat, a prime number is a positive integer or positive whole number that is divisible by itself and 1 and exactly divisible. So there cannot be any remainder when you are dividing this prime number by itself or by 1. Okay, and it can only be divided by itself and 1 and no other numbers. Okay, so two criteria for prime number. Number one is that it has to be a positive integer, and second criteria, divisible exactly by itself and the number 1 only and no other numbers, right? So having said that, the first prime number that we see is actually 2 and not 1, right? So 1 is not a prime number, so 1 does not equals to prime. The reason for this is that 1 is only divisible by 1, which is itself, and it's not two different numbers. You have to be divisible by two different numbers before you're considered a prime number. Okay, so the first prime number that we've listed down here is 2, followed by 3. Now 4 is not a prime number. Why? 4 is not equals to prime, because if you look at the number 4, it can actually be divided exactly by 4. It can also be divided by 2. It can also be divided by 1. So there are actually three different numbers here, and this does not satisfy the prime numbers criteria. Okay, so the next one is 5, followed by 7. Now again, the number 6 is not considered as prime, does not equals to prime, because the number 6 can be divided by 2, by 3, by 6, and also by 1 exactly. So there are 4 different factors to the number 6. So this does not satisfy the prime number criteria. So 2, 3, 5, 7, and again all of these that I'm writing down here, they are all known as prime numbers. Okay, 2, 3, 5, 7. The next one will be 11, 13, so on and so on. Right? So the usefulness of prime numbers is really to help us solve mathematics questions that involve highest common factor, lowest common multiples, amongst other useful activities that can be done with these prime numbers. Right? So let us just try some questions on HCF and LCM. So say for example you are required to find the HCF between two numbers, right? So HCF, highest common factor between two numbers, say for example 14 and 35. Now the longer way to do this is actually to list down all the factors of 14. So factors of 14 includes 1, 2, 7 and 14, right? And you do the same for 35. Factors of 35, you have 1, you have 5, you have 7, and you have 35, right? You list these factors down and then you select the highest common factor between 14 and 35. Okay, so from the offset you can see that 7 is the HCF of 14 and 35. Well, there's actually a simpler way to do this. That is to first express each of these numbers into its prime factor form. Right, so first we express 14 in prime factors form. So the way to do this is to draw a simple table like this, right, and divide 14 by the smallest prime factor that you can think of. So 14 can actually be divided by 2, right, and that gives you an answer of 7, right? So 7 can be also be divided by 7 to give you an answer of 1. So once you reach 1, you actually know that 14 can be expressed in terms of these numbers here, which is 2 times 7. So 14 is actually 2 multiplied by 7. So you do the same for 35. So let's draw the same table for 35. Okay, express this in prime factors form. So first divide 35 by the smallest prime factor. So 35 can be divided by 5 first to give you an answer of 7. 7 can be divided by 7 to give you an answer of 1. So once you reach 1, you know that you have expressed 35 as prime factors here. So 35 is actually equals to 5 times 7, right? So you put the numbers side by side. So basically express 14 in prime factors form. So 14 is equals to 2 times 7. 35 is equals to 5 times 7. Okay, so the HCF is actually the lower of the powers here. So for example, you are comparing 2 in 14 and 2 in 35. There's actually no 2 term here in 35, so you do not put a 2 here, right? However, there's a 7 term. Okay, so you would take 7 as your answer. Okay, so let me just elaborate this again. So basically this first step is to express 14 and 35 into prime factors form. Write it down here. So once you have written it down here, the HCF is actually the lower of the power. So say for example you have a 2 but you don't have a 2, the number that you put here is the lower of the 2, right? So in this case you do not put a 2 because there's no 2 here in 35, right? And then you compare 5, there's a 5 here, there's no 5 here, so you do not put a 5 here. There's 7 in this term and also a 7 in this term, so you will just put a 7 and this is your answer, which is the same as what we got previously. Okay, so in the next video we'll be talking more about HCF and LCM using our prime factors knowledge.